Hey Math Stars, this problem asks us to find the approximate value of y equals 2 root x at x equals 1.2 obtained from the line tangent to the graph at x equals 1. Well, we're finding the line tangent to this function at x equals 1. So let's go ahead and start with that. So we're going to find an x1, a y1, and an m. x1 was the x equals 1 that they gave us. We're going to use our function 2 root x, and we're going to plug in our 1, and that's going to give us our y1 value. So y1 is equal to 2. We need a derivative in order to find our slope. So as you know, when we take a derivative, our constant goes along. And then we're taking the derivative of square root x, and y'all have that memorized. That's 1 over 2 root x. So in our derivative, the 2's cancel, and we're left with 1 over root x. Okay, plugging our input into our derivative, we get 1 over root 1, so our slope of our tangent line is 1. Now we're going to use that information we just found and write our tangent line equation. So we have y minus 2 equals 1 times the quantity x minus 1. Okay, we're going to use our tangent line equation, and we're going to plug x equals 1.2 into our tangent line. And then that's going to approximate the output of our graph at 1.2. So we have y minus 2 equals 1 times 1.2 minus 1. Now we can use this equation and solve for y. So we have y minus 2 equals 0.2 when we subtract. Adding to bring the 2 to the other side, we get y is 2.2. So we approximated y of 1.2 to be 2.2. Okay, let's take a look graphically at what's happening here. By the way, that's our answer. Let's just go ahead and talk about the meaning of what's going on here. Okay, so on our graph, we're going to plot the function 2 root x. So the y values of the square root function are all doubled. So it goes through 1, 2, and then 4, 4. We found a tangent line equation to this graph to be y minus 2 equals x minus 1. Let's bring that 2 over by adding it to the other side. And so in slope-intercept form, that graph is y equals x plus 1. Let's go ahead and draw in that tangent line. So the y-intercept is 1 and the slope is 1. So these would be the points that would be on our tangent line. We can draw that tangent line in there. So you can see when we are close to an x value of 1, our tangent line is a close approximation to the graph. So that's what's happening. The tangent line just lies a little bit above the graph, but at 1.2, we can use our tangent line to approximate the value of the function. So our tangent line approximation that we found was, over here, was 2.2. And that's a close approximation to the graph because our tangent line lies very close to the graph. So basically that's what we did when we found our tangent line and then plugged in 1.2. Okay, next one. The function f is twice differentiable with f of 2 equals 1, f prime of 2 equals 4, and f triple prime equals 3. What is the value of the approximation of f of 1.9 using the line tangent to the graph of f on x equals 2? So we want the equation of the tangent line to f at x equals 2, so we need an x1, a y1, and an m. So as you know, when we plug 2 into the original function, that gives us our y1. So using this information, f of 2 is 1, our y1 is 1, and as you know, when you plug the x1 into the derivative, that gives you your slope. So f prime of 2 equals 4, 4 is going to be our slope. Just like before, we plug those in to get our tangent line equation. So that gives us y minus 1 equals 4 times the quantity x minus 2. So to use our line to approximate f of 1.9, we plug in 1.9 for f. Subtracting, that gives us 4 times negative 0.1. Multiplying here, we get 0.4, negative 0.4. And then lastly, let's bring that 1 over and add it to the other side, and we're going to end up with 0.6. So again, what we just did is we approximated f of 1.9 to be 0.6 using our tangent line. Okay, so our answer to this is B. We gave us some information we didn't need. We didn't need that f of f double prime of 2 is 3. And after we found our tangent line equation, we plugged in 1.9 for x. Okay, go ahead and try the rest of these problems. Help your neighbors. You got this.